All right, guys, here we go. We're on 11.6, I believe. Yeah, 11.6. This is part 2. So we're getting into a little bit more graphing than we have. So we're going to use some of the stuff from the first part of 11.6, and we're going to use input-output tables to find the period and the graph of the function. And then at the very end, I'm going to show you how to evaluate trig expressions using the unit circle. So I've pre-drawn this, so if you want to stop the video, I would look at page 683. I'm going to go over example 3 for you guys because it's already easier because they have pictures and stuff. But they're using the picture on the top of 682. So just to show you guys, here's where I'm working, but they're using this picture on the top left. And I drew that picture right here, but theirs is way better than mine. Mine's just kind of a funky little deal. Let me go. Hopefully that you guys can see this. I won't know until after the video, but if not, just refer to the picture on the top of page 682. So once we do input-output tables and we're dealing with the graph of a function, I'm always working on NA, graph, numerical, algebra, words. Well, on this particular problem, we're going to use numerical and graph and maybe a little bit of words. We're not going to really do any algebra today. So this is just great for setting up your problems, and if you get used to it, you may not use all 4, but we'll go from there. Make sure you label what the x-axis is and what the y-axis is so you can keep track of stuff. So let's talk about what they want. They want us to make a table, and which is I have drawn up there. We'll make that table, we'll identify the period, and then we're going to graph the function. I would actually do it opposite. I would do the third part. Once we make the table, I would graph it, and then I would use the graph to find the period. So that would be the best thing you can do. So you're on a bicycle, and you have a pedal here. My pedal's in pink, and when you start pedaling, your foot goes down to the bottom, back around, back to the top, and then it just keeps going in a circle. Well, if it goes in a circle, it's based on the unit circle, so therefore it's a periodic function and it repeats itself. That's the key piece. So let's look at this. So x is seconds, all right? So x is seconds. So at 0 seconds, my pedal, this is supposed to be inches, my pedal was 18 inches off the ground. And then I'm going to go ahead and I'm going to graph this. I'm going to start at 0 seconds. And I'm going to go 0.5, 1, 1.5, 2, 2.5. You can go to 3 if you want. It doesn't really matter, but I think they go to 3 in the book. Yeah, they go to 3. But you'll see the pattern here. Okay, and then I'm going to go with height. I'm going to go, oops, in fact, I'm going to redraw this, guys. Sorry, so I can get the right height there. So this is my height. I have 18, I have 11, and I have 4. And I have 0 seconds, 0.5 seconds, 1.0 seconds, 1.5 seconds, 2.0 seconds, 2.5, and 3. And this is seconds. And this is height in inches. Okay, so this is my y-axis. This is my x-axis. So we're still dealing with that stuff. This is where old stuff comes back into play. So hopefully that was a good review for you guys. So I'm going to change no, I'm not. I'm going to keep it the same color. Forget what I just said. So if we start at 0, I got 18 inches high, the height of the pedal. When I pedal 1/4 of a turn, it took me 0.5 seconds, and my new height is now 11 inches. When I go pedal all the way to the bottom, it took me 1 second, and my height is now at 4 inches off the ground. When it comes back around, it goes up to 1.5 seconds, and my height is now back up to 11 inches. And when I get back to the top at the end of 2 seconds, it's back to 18 because it goes in a circle. 18, 11, 4, 11, 18. 18, 11, 4, 11, 18, 4, 11, 4, 11, 18, 11, 4. So it keeps going in a circle. Well, if you do that and you ride the bike out, so you ride the bike out, it actually starts making a motion that goes like this. So let's graph that and see what it looks like. So I'm going to use the same color. At 0, I'm at 18 inches. At 0.5, I'm at 11. At 1, I'm at 4. At 1.5, I'm at 11. At 2.0, I'm at 18. At 2.5, I'm back down to here. At 3, I'm back down to here. So this thing starts to make a motion. And since it's on a circular path, your graph is curved. And we'll get to that soon. So our graph looks like this. Okay, now, remember the period, so we've graphed it. We've created the input-output table based on the height in seconds. We've graphed it. Now what we want to do is we want to find the period to complete one cycle. So what does it do to complete one cycle? Well, one cycle goes from 0 all the way around to 2 seconds. So from 0 all the way around to 2 seconds. 0 all the way to 2.0 seconds. At 2.0 seconds, this repeats itself again. So the period is 2.0 seconds. All right. So that's how you have to graph these things. So make your input-output table. That's probably the hardest part. Use the diagram or the information that they give you. Graph it, and then find out how long it takes to repeat itself. That's the period, 2.0 seconds. You guys can practice guided practice 3. So you guys can do guided practice 3, guided practice 3A and 3B. And I'll scan the answers up so you can see the picture in whatchamacallit, Edpuzzle for you guys. All right, so let's go tackle this last little bit. Here we go, guys. So, erase that. And we're going to take something, so we're going to evaluate. So we're going to do evaluate trig expressions using the unit circle. So you're going to see something like this. The sine of 45 degrees minus 5 times the sine of 30 degrees. And it's like, really? That looks hard. Remember, we're dealing with the same stuff over and over and over again right now. So this is why I say using the unit circle. Get your unit circle out. It's going to be super helpful on these problems. So if we get our unit circle out, if you haven't memorized, more power to you. And we look up the sine of 45 degrees. Remember, the sine of 45 degrees is when you're looking at the unit circle, it's always the y value. Y value is always the sine of theta. So what's the sine of 45 degrees? This particular one, it's root 2 over 2. So now we've got this 5, which just stays there, because I'm going to put parentheses around this. Remember, we put parentheses around this, it means multiplication, and that's what a number in front of another number means. So the sine of 30, if you go to the unit circle again, you're going to see a point that's root 3 over 2 and 1/2. Well, sine is always the y value, so we're going to do times 1/2. So now you guys are all panicking because there's fractions involved. Let's just clean this up a little bit. Remember to rewrite a couple of different things. Leave this one alone right now. There's nothing you need to do to it. Now we've got this issue to deal with. All we need to do is remember to put this over 1. And when you're multiplying fractions, you multiply straight across. So we're going to get 5 over 2. And we're going to get root 2 over, now I'm going to do something a little different here, 2. Okay, the reason I did that is we have common denominators. If there's a common denominator, we keep it and we combine the numerators if possible. Root 2 minus 5. Root 2 minus 5. Keep the denominator. And if you may see it as an equivalent, which is an or, it's that answer or I just rearrange it, and you may see this in certain types of situations. That and that are the same thing. So either answer is acceptable. Just use your unit circle, set up the fractions, subtract the fractions, and you'll be able to tackle your answers from there. That's how we evaluate trig expressions using the unit circle. Using the input and output tables, finding your period and graph the function. Make sure you use the input output tables and the information provided. Have a good one, guys. We'll see you soon.